Hey students, it's Mrs. Marshall. This is my mini lesson for you about circle theorems. So I'm going to do a brief description of what you've been learning in class. So let's start by looking at a simple circle. The first thing you need to know about a circle is that it's going to have a center point. The center point is equal distance no matter where I look from the circumference. So here's my center. No matter which way I go, it will take the same distance to get to this line out here called my circumference. From the center point, I can also draw something called a radius. The radius is only one line from the center of my circle to the circumference. If I take the radius and I extend it through the center in 180 degrees, that is called a diameter. So this is my radius, and this is my diameter. In another circle, we're going to talk about arcs and sectors. There's my sector. This is my arc. So if you were to think about it, this arc is like the pizza crust to my pizza. So here, my pizza slice is my sector, and out here is my arc. Another piece of a circle you could have is when I draw a chord, which is a line jutting from one side to the other side of my circumference. This is called a segment. And again, to create a segment, I need to draw a chord. So right here we have three pieces of information. I've given you information about the center of a circle, a radius, which is half of my diameter. I've given you information about a sector, which is a slice of the pizza, if you will, of our circle, and our crust is our arc. If I create a chord, I create then a segment of my circle. A segment is just a piece of our circle. I can draw a chord anywhere. Next, I'm going to do one example of finding either radius or diameter in a circle. Here's our circle. Here's my center. I'm going to draw a radius. My radius is 9 meters. I'm trying to figure out what my diameter is. So if my radius is 9 meters, I know that my diameter is radius times 2. So I can plug in 2 times 9 equals 18. So my radius is 9 meters. My diameter is 18 meters. Next, I'll be showing you how to find circumference. Here's our circle, and our formula to find circumference is 2 pi r. So 2 times pi times radius. Our radius in this circle is going to be 6 inches. In order to solve for a circumference, which is this entire pie crust is 2 times pi, in this case, 6. So on my calculator, I'll be typing in 2 pi 6. My answer is 37.69 inches. That is the length of this entire pie crust. If I were to unravel it, if I were to cut it right here and unravel it all the way across into one long line, if I were to unroll it, it would be 37.69 inches. Now I'll be showing you some of the theories or the theorems of circles that we taught you today in geometry. Our first one will be concyclic points. So here's my circle with the center point. Concyclic points are just any points along the circumference of a circle. And they don't have to be even. I could have a bunch here. I could have one here. Wherever they want to be, these are called concyclic points. In order to remember the name of this theorem, you could think of cyclic being similar to cycle, like a bicycle. Okay, concyclic points. Our next one are concentric circles. So here is my circle. Here is the center point. Concentric means that all of the circles are going to have the same center point. Concentric. Center. Same center point. Same center point. All the way in. You could think of Russian nesting dolls if you're aware of what that is. Okay, these are called concentric points. Or concentric circles. Okay. Next, we'll be talking about the ideal situation of having a circle with a center point and then points along the circumference. And it turns out to kind of look like that emblem from Star Trek. All right, so the idea is this. The angle that is right here at theta, so this is our theta, is half of this angle. In other words, this angle is 2 times theta. So, for example, if this angle is 40 degrees, this angle is 80 degrees. That idea also works with this circle. So I have a center point, a radius coming from the center point, a chord coming across, and then a diameter coming all the way through the center point, right? Here are my points. If this inscribed angle is theta, this angle coming from my center point is also 2 times theta. So again, if this is 40 degrees, this angle is 2 times 40, or 80 degrees. Another example of that is with this circle. Here is our center point. I am going to create some radiuses coming out, a couple chords. Here are our points. Okay. Whatever this angle is, here's our theta. This angle, again, is 2 times theta. So if this angle is, say, 110 degrees, this angle is going to be 2 times 110, which means this angle right here is 220 degrees. One last example of this theorem is if I have a center point and I draw a cross and I make myself a triangle, I know that straight lines are always 180 degrees, correct? But what I also know is that this angle is also twice theta. These are two facts. This angle is a straight line, therefore it's 180 degrees. I also know that any angle coming from my center is twice theta. This means this angle in this corner must be half of this angle. Half of 180 is 90. So that tells us that theta is actually a right angle. Our next circle theorem has to do with supplementary angles. I'm going to create a shape, a quadrilateral, within this circle. Here are my points. So this is what we call a cyclic quadrilateral. Cyclic quadrilateral. A quadrilateral is any shape that has 4 sides. Cyclic means it has to do with a circle. So this is a quadrilateral within a circle, cyclic quadrilateral. So if this angle over here is x, this angle over here is y, this angle over here is 180 minus the supplementary angle, y. This angle is 180 minus the supplementary angle, x. So an example of that would be if I have a circle over here with a shape that has 4 sides, within a circle, a cyclic quadrilateral. This angle is x, this angle is y, but this angle over here is 70. This angle over here is 120. I want to find x and y. X equals 180 minus 120, which is 60 degrees. That's a 60-degree angle right here. Y is 180 minus 70. That's a 110-degree angle. So now we know that y is 110 degrees and x is 60 degrees. I'll be going over 3 more brief circle theorems. These are very quick. Our first one is that from the center of a circle, I'm going to create a couple sectors. If the arc right here is one number, it is the same as this. If the arc is equal, if these are the same, the sectors, this space in between, are also equal. It's the same idea. Imagine this is a piece of pizza, and pizzas are cut up evenly. If the crust of this pizza is, say, 6 inches, so is this piece of crust. And that means this crust, or this piece of pizza, is the exact same size as this piece of pizza. The next theorem I'll be going over is that from the center, if I draw chords, the same chord all over, this is the exact same length of chord, all over my circle, the distance from the center will always be the same to the chord. This line will always be, for example, 1 inch. This is an example. If this line is 1 inch to this chord, and the same chord is put in different places, this distance will always be 1 inch for this example. My final circle theorem is more of a tangent theory. Here's a tangent, and that is just a line that is touching the outside of a circle evenly. It is just a ball or a circle sitting perfectly on a desk, for example. All this theory says is something very obvious. From the center of this circle, imagine this is a tire standing on a road. This straight line from the center straight down to my tangent is 90 degrees. Very obvious. If I have a perfect tire or a donut or whatever you want to wish it were, if I take from the center of that circle straight down to my tangent, it's 90 degrees. It creates a 90-degree angle. And that is all of our circle theorems. If you have any questions, come find me, Mrs. Marshall, and I will be glad to show you.